Hi there, guys. My name is Coleman or Cole, and I'm the co-founder at MarsU and the co-director of our Mars Studies program. And welcome to today's exciting conversation and our open house about our awesome Mars Studies program this upcoming June. So for our, let's see. For our agenda, we'll have three primary speakers, myself, and then Jekan and Bruce. And I'll be presenting for around 15 or so minutes, and then followed by a 5-minute open discussion until Jekan's presentation. And feel free to share your ideas, comments, and questions in the chat or verbally, or mention them during the Q&A afterward. And this entire presentation will also be uploaded to YouTube. Okay, so we are offering a certificate in Mars Studies this upcoming June. 6 weeks. It will be in person, and remote participation will be allowed, but in person will be strongly encouraged because it'll be much more of a meaningful experience, and you'll also learn much more. And so we'll have up to 36 students, over 12 faculty and staff, and a whole lot of guest lectures and speakers. And we're excited to be partnering with the University of Arizona to host our Mars Studies program, and then in collaboration with local makerspaces in this the beautiful city of Tucson, Arizona. Just it's close by close to Mexico, far down there, but it's really a wonderful, probably one of the and really a wonderful city, and I think it's one of the best cities to host our first summer program in terms of what they've accomplished to become multiplanetary. And so we're planning and offering a project-based curriculum with over 4 courses for around 20 to 30 plus hours per week, with all sorts of exciting labs and workshops and research team projects. And we encourage you to apply here with the program link. Yes, and yeah. So here is our our founding Mars Studies program staff. So Daniel Tompkins is our faculty for agriculture, and Jekan just introduced himself as well. He'll share more about what he's doing and collaborating with the University of Arizona afterward. And then Thorsten is helping lead our logistics during the program. And Abhishek here is leading IT operations on site. And Sarah Sabri will be one of our teaching associates, along with a few other people who will be our teaching associates. There's a lot of well-accomplished people, who are interested in participating, and there's a lot of opportunity to get involved and really participate in a lot of workshops and projects and events. Yeah, so here's the application. It opened November 15th and closes on January 15th. So it should have said 2021 there. Need to update those. But yeah, each applicant will be automatically considered for up to a 33% scholarship after submitting the application. And you'll be required to be at least a rising junior or senior, or in a bachelor's program or graduate of a bachelor's of science program, and will require 1 letter of recommendation and a letter of intent as well, where you can really outline how you'd like to contribute to during the summer program, but then also the application allows you for the opportunity to help communicate to us and our team about the what kinds of research and knowledge you'd like to learn about and develop to really make it tailored to everyone's interests and passions. And so for the tuition, scholarships, and financial aid, we're planning to the tuition will be around $7,500 for 6 weeks, excluding scholarships. And so yeah, it'll be around $1,666 for lodging for 6 weeks, and then $2,400 for the meal plan, and the rest will help support our faculty, staff, and the program and curriculum, and but then research too. And so and this will likely be really one of the more affordable summer programs. Yes. And we're open to payment plans and meeting people, and we're actively looking to collaborate with potential partners and sponsors to help make this more affordable as well, for each student. And so here are some interested guest lectures. Really well-accomplished people. Rob Mueller, he's the co-founder at the Kennedy Space Center SwampWorks, and works at Lunabotics. And Grant Anderson is the president and co-founder at Paragon Space Development Corporation, and we all know Dr. Robert Zubrin here, and he's excited to lecture during the Mars Studies program during our conversation at the Mars Society convention. And we also discussed with Pete Warden last summer in Strasbourg during the Space Studies program, and he's also interested in lecturing for us here and attending in person. And so the University of Arizona here, here are some of the 4 primary departments that have really pioneering the way out into space and the stars. And so there's the College of Aerospace and Mechanical Engineering. There's the Lunar and Planetary Laboratory, LPL, and then there's here the Arizona Space Institute and the Lowell Institute for Mineral Resources. And the Lowell Institute, it is really it's been referred to as the Silicon Valley of mining, and it's one of the top 25 research institutions with a lot of world-class labs as well. And so there's really a lot of equipment and facilities and knowledge and people in the Tucson area that could really help advance this program, our knowledge, and all the above. And so the participant staff and faculty were likely going to be at Coronado Hall, and for the dorms and lodging. But we're in discussions with housing residents and staff there. And the chefs on campus, they're quite excited to cook the Mars meals for us. And yeah, next slide here is about the makerspace, the University of Arizona Catalyst Studios. They've really done an excellent job here in enabling this makerspace and project-based learning. And so there's all sorts of exciting workshops they host, and labs and team projects. They have a maker studio, which is near the library, and then a virtual reality studio as well. And then also a data studio down here on the bottom left, where we can develop our computational skills and really actually visualize a lot of data. And all sorts of exciting makerspace tools. And so, each of us, we can each get certified in 3D printing and laser cutting, and then also apply this to our research and knowledge and projects. And so our goal, as a team, is to really help you develop the skills and the mindsets to learn how to design and engineer life and systems on the Martian surface. And to really familiarize with the systems, tools, and equipment beforehand, and conduct the science, both on paper and in person, and so we can really begin to almost like replicate these Martian labs, and even like these tools and these maker spaces, and almost simulate and emulate what humans and robots would do in unison on the surface, and in addition to all sorts of field sites and classrooms. So yeah, here's some more details on Biosphere 2 here. It's I think hope we've all heard of Biosphere, but it's a 3.14 acre closed loop biosphere. It's one of the largest ever, and it was constructed in the late 1980s, and it has 7 biomes, and human habitats and labs. And so we're planning a weekend trip, and in discussions about hosting some exciting workshops and field tests and labs on site here with Biosphere, and in addition to collaborating with them. And so here's some local field trips in the Arizona area. There's a desert laboratory, which is an ecological preserve. There's the Kitt Peak National Observatory. It's really done a lot of astronomical observations, both in the optical and infrared. There's the Mirror Laboratory. There's the Mount Lemmon Sky Center, and there's also the Mineral Museum. And so there's so many places to do and things to do, and they have a lot of really cool space telescopes as well, and renowned observatories. And a fun fact, 52% of all of the known near-Earth asteroids and comets were discovered by the University of Arizona. So that would be a majority of near-Earth asteroids. And there's so many exciting Mars analog environments as well. Here we've outlined a lot local here in the Arizona area, and it's really this perfect environment with the red iron oxide, and there's all sorts of sites to study, and so we can really discuss and plan about these kind of program-wide and team-level field tests and labs at at these really historic geology sites. And so, yes, we should definitely go study and observe the Grand Canyon, and these other canyons, and let's publish a study to really help improve the habitability of Valles Marineris. I think that'd be pretty awesome. And here's our last slide here. This is more about our call for research experiments and team projects, which is really holds a lot of potential and is quite exciting as well. And so in the student application, the participants we can submit our application and outline in the essay more about the research that we'd like to do, and so that'll give our team a better idea of how to develop the program, and then so on site we can jump into small teams with the participants, and then we can select and develop these research projects with all sorts of access to equipment and local facilities here, and then we can plan some kind of like project review periods, and then followed by the 6th week where the team presentations can be live streamed during the final week. And the goal here is to make this program and the research really inclusive, such that the lecturers can come in and also help advise, and with the staff and faculty, we can all kind of help develop each project cohesively, and so we're the winning team with the best idea to make life multiplanetary could receive up to $2,500 to $5,000 grant, is what we're considering currently. And here's let's bring all these cool gadgets and equipment that we've accumulated together into one place, and really learn how to apply these skills over our lifetimes and into all these projects, and so our team is in some exciting conversations about research and experiments, and all sorts of things, from like a robotic end effector to materials testing, regolith testing, soil testing, and then it'd be really cool if we could almost like collaborate with the industry and people to help develop their research and projects as well with what we have. So yeah, I think that's it for our presentation. There's all sorts of exciting cultural activities as well. There's Mars Jeopardy, Mars Trivia. We can also discuss about having some sort of open mic night. And Bruce was discussing about a weekend overnight camping trip. Yeah, I think we're also planning to submit an Nsf grant in late January, and we'd really like to make this program democratic and with the decision making and planning, and which is inclusive of participants and staff. And so if you plan to apply and would like to join in one of our team meetings, let us know. We host these bi-weekly planning meetings where we really come together and figure out how we're going to develop and coordinate this program. So thank you for listening, and can open up to questions and comments in over the next few minutes before Jekan's presentation.
And Cole, I'd like to add, at the end, I will come back and talk about the different workshop opportunities and suggestions, and try to get people's input. But go ahead, Jekan.
Sure, thank you. Let me start sharing the screen here. Can everybody see the screen?
Yes, we can.
Okay, fantastic.
Yes, let's see.
Okay, thank you.
Okay.
So let's just sort of get started, just to give you a little bit more background about University of Arizona. We're the flagship university for what used to be the territory of Arizona, now a state, formed in 1885, and we're located in the city of Tucson. There are about 45,000 students, 3,000 faculty, and University of Arizona is one of the 62 AAU universities. Top-notch research going on, and oftentimes it's been well ranked in physical sciences, engineering, and medicine. And we're part of the Sun Corridor, where there's a lot of activities going on in aerospace, optics, electronics, and manufacturing, spaceport. So there's almost this continuum of activity going from Southern California towards New Mexico, and we're in the middle of that. And so with our university, space missions has been a big area of focus. Ground observations, as you heard from Cole, two of the leading asteroid discovery groups there, Catalina Sky Survey and Spacewatch. Majority of the near-Earth asteroids have been discovered out of University of Arizona's telescopes. Then there's new work going on with exoplanet observation, a lot of growing interest there. The recent black hole discovery, we had folks participate out of University of Arizona doing that. And there's of course growing efforts in space situational awareness and space debris cleanup, space threat observation, and even Earth observation now. As a university, it's been a leader in planetary science, one of the leading universities to have a number of papers and citations per year, next to, of course, NASA. And U of A folks and alumni have been involved in every major mission to every major planet or major body in the solar system since the 60s. And so quite a illustrious history here. Just a bit of background about myself here. I have a background in engineering science, aerospace, coming out of University of Toronto, and I moved to Arizona about 8 years ago. But my background is in space robotics and planetary robotics systems, and I've been an assistant and an associate professor here at University of Arizona. Some of the stuff that we do, heavy emphasis on planetary robotics and space robotics, of course, but we also look into longer term technologies and trends, exploring the extreme environments of Mars, colonizing Mars, looking for water, and how to really end up building up a spacefaring civilization. Having said that, I wanted to sort of get into and give you a glimpse of what the course is going to be like, particularly about exploring Mars, which I'll be hosting. And there'll be three major thrusts to this. There'll be a science thrust, an exploration thrust, and a systems engineering thrust. So the science thrust will be looking at the past, the present, and future efforts to explore Mars using robotic technologies. The exploration thrust will be to give you a virtual field trip to Mars, present some of the unsolved science, the geohistory, give you guys a taste of being on the front lines of Mars robotic exploration. And then finally, on the systems engineering front, it'll be giving you guys some practice of practicing system engineering skills to identify science mission goals, conceptualizing missions, prototyping spacecraft technologies, all in an effort to better explore Mars. And so the course will highlight some of these major subtopics, which include Mars formation and geohistory, the field trip to Mars, which we just talked about, the moons of Mars, missions past and present, and a big highlight, because we have this hosted out of University of Arizona, which is a high-rise imaging system that takes these 0.3 meter per pixel images of Mars from orbit. Really fantastic images. And of course, the bigger question, search for life, what Mars Science Laboratory and Mars 2020 are doing, upcoming efforts to do Mars sample return, and of course, future missions to Mars. The course structure will be typically about 2 hours of lecture, interspersed with all kinds of videos, movies, and active events, in addition to about 2 hours of activities, which will culminate into a team project over those 2 weeks. And so these team projects will be a mix of conceptual, software simulation, and physical demonstrations of concepts. We'll often have folks form into teams and compete in teams, all for fun, of course. And as Kolemann mentioned, it'll be interspersed with programmatic field trips. All the great places like Biosphere 2, of course, the OSIRIS-REx Science Center, and the telescope sites that Cole mentioned, and not to mention the Flandreau Planetarium. And I just wanted to get into one last bit to talk about U of A's illustrious history in Mars exploration, particularly, I would say, the modern chapter. And that goes all the way back to Mars Observer. It was an unfortunate incident. This craft exploded, but it carried a gamma ray spectrometer from University of Arizona. Then came Mars Polar Lander. It too failed. Very unfortunate. A lot of us were waiting for that landing that day. Never happened. And then came Mars Odyssey, which was a success. And it carried a gamma ray spectrometer. And we got lots of great data from it about water quantities, particularly in the South Pole. In terms of some of the major highlighted discoveries, Gerard Kuiper, who founded planetary science at University of Arizona, he helped discover CO2 in the atmosphere and tried to figure out in the early days why at times Mars might have looked green. Brad Smith is another gentleman who led the Viking orbiter mission, but was a major imaging team expert on the Viking project. And then, of course, Mars Pathfinder, which is really, I think, the start of modern exploration of Mars. It was this, low-cost mission that landed in 1997, and it was the first successful mission in 20 years. Lots of great pictures came out of it, a lot of great PR. The cameras out of that mission came from Peter Smith, and it gave you 3D images out of these. Thanks to being stereo, this then got transplanted onto a lot of other missions, including the rovers. And Peter Smith went on to lead NASA's first university-led mission, and this was the Mars Phoenix lander. And it ended up that the mission was actually Peter Smith's PhD thesis. And so the mission landed successfully in 2008, got all these great pictures. This is in fact the team behind it, and this nice, really, really nice mural. Tucson is famous for a lot of nice murals around, so you'll get to see that all around the city. And I just wanted to say this was the money shot, the great picture that made that mission all a success. As you see, a robot arm, sort of dug into that soil here, and you can see those white spots. That's in fact water ice. And so this was the first time water ice was, without doubt, photographed on the Martian surface. And that ended up completing Peter Smith's PhD thesis. So what else is new is the high-rise camera I was just mentioning about. This gives you unprecedented detailed images of the surface of Mars from orbit. In fact, we're getting better images of Mars than of Earth right now. And this is headed by Dr. Alfred McEwen, a friend of ours. And he has a center there right on the mall in U of A. Great place to go out and see. Lots of images, lots of galleries just to see all the cool things that we've discovered over the years. Even watching other missions, such as this parachute landing, dust devils, and of course the mysteries. So one of the remaining mysteries on Mars are these recurrent slope lineages. So what seems like riverbed flows or water flow from crater rims. But the problem is, as we use our sensors, we don't seem to detect any water. So what's going on? And this is really the mystery. It seems water-like, but yet there's no water. And so that's an ongoing thing. And I just wanted to say, the next new chapter is sending out a whole new set of planetary robotic platforms and tools and missions. And so one of the things we've been looking at is these small ball-sized robots called pitbots that would go into trenches, that would go into nooks and crannies in hard-to-reach places that the rovers couldn't go. Another is a sailplane that we work with our collaborators at the University of Arizona and NASA Ames. These are planes that don't have to carry any fuel. They rely on Martian wind. They may be moved from place to place using balloons without having to have any, sort of fuel-based propulsion system. And so these missions could, ideally, go for long periods of time. And here's a sort of a balloon-based system. And these are all being developed by teams of students and researchers. And of course, Arizona is a great place for setting up analog sites. And with that, thank you, and I would be happy to take your questions.
I had a question about the pit bots. How are these like how do they maneuver? How are they propelled?
Sure. So we are looking at three major options for those pit bots, and I can just go back. One is using some kind of liquid bipropellant. It could be hydrogen oxygen is one option. If we're going on an astrobio mission, though, we would need to stay away from the water, of course, water as a product, or hydrogen oxygen for that matter. And there we've also looked at solid rocket fuel, perchlorates, ammonium perchlorate. And then we have also looked at, I would say, green monopropellant. That's the safe alternative, the relatively safe alternative to hydrazine. It all depends sort of on context, how much gravity you might have to overcome. On Mars, it's 1/3 of that of Earth. And then we're also looking at mechanical hopping as well. So that's also an alternative. But by doing that, it's mostly going to be hopping, but rarely hovering as well as need to be. But that's the sort of its mobility capabilities there.
So I actually had one more question, or another question. For the Mars exploration course, you mentioned there's simulations. Are you using particular simulations in a course like Gazebo, or and I guess like a follow-on question to that would be like, what would be a good way to prepare? What are some good ways to ramp up so that during the course we'd be able to execute on a project pretty well? Sure.
Generally, I always encourage self-guided journeys. If you're interested in Mars, go out and get books to read up on Mars, read up on what's going on in terms of the latest exploration, what's the latest findings. The software that you mentioned, like Gazebo, is one of the software that we actually use for our rovers, but we have several others as well. It's gotten to be a quite a nice ecosystem of different software. It sort of specifically depends on what particular simulations you guys are trying to do. So if it's of course a rover or robotic simulations, Gazebo is definitely one example, and we have several others. And then there are also simulation tools for doing trajectory design. Such as Systems Toolkit. It used to be called Satellite Toolkit from AGI, who often sponsors our student activities. And then there are other similar tools as well. So it depends on context. A lot of these simulation tools are now also freely available from all kinds of resources, if you sort of ask or know the right connections. But general interest, following up on the types of activities that's going on, following up on really, in many cases, the context of what's happening really helps. I think really pays things, and so we will also be giving guides on that, additional context, additional read up material, additional preparation type stuff, but. Definitely, that's always a great thing to have.